Good morning once again and welcome to this lecture. This is lecture number 5. And in the previous class, we had dealt with intensity and energy and power of the wave. Do we remember this?
Yes, sir.
Very important concept of intensity of the wave because that is the main function of the wave. What is the main function of the wave? What does the wave do?
What does the wave give in a relay action?
What does the wave do? Forgotten.
Transferring the energy, sir.
Transferring the energy, sir, and that is the main concern that a wave must travel. I mean, the wave must transfer energy. The only wave that does not transfer energy is a standing wave, which will be coming very soon, maybe in the next class. The next heading is superposition of wave, and we have already done this heading. We have already done this. Where we have done this? Huh?
Yes, sir.
Where we have done this?
In SHM.
In SHM, we have seen the superposition of wave, and what we had seen, if we have one or if a particle executing one or more SHM, the resultant displacement is the sum of displacement due to all the SHMs. Here, two or more waves can propagate in the same medium. Right now, I'm speaking, I'm creating sound wave. I don't know, there are a lot of noises coming from outside. That is also sound coming to me in the same medium. My sound waves are traveling, the other sound waves are also traveling. You can hear my voice, and I can think you can hear your each other's voice as well as the voice of the fan that is moving above you. All the waves are traveling in the same medium. Still, you can identify each wave. That means more than one wave can travel. Now, when one wave travel, it causes displacement of the particle. The particle execute SHM. So particle is executing SHM because of all these waves. The net resultant displacement becomes the sum of the displacement produced by all of the waves. Yes or no? No or yes? So that is what we call the superposition principle. It is very simple to understand, simple to see. The same superposition principle is applicable for any type of vector, any type of force, any type of velocity. Everyone understand this? Yes or no?
Yes, sir.
That is the principle of superposition of waves. The resultant displacement of any particle when it is subjected to more than one wave, more than one SHM, more than one simple harmonic motion, the resultant displacement y is the summation of yi. Do we understand this? Do we understand this, or this is going Baba is saying bye bye? Huh?
Understood.
Now in this section we will be hearing about two types of superposition. Superposition principle is what I have given here in the pink thing. Superposition of waves. The net displacement due to all the waves is the sum of displacement. That is known as the principle of superposition. Now, because of this principle of superposition, we will be doing two types of phenomena. Because of this superposition principle, we will be doing two types of phenomena. One is known as interference of waves, and the other one is known as beats. First, we will be dealing with interference. Beats we will do with sound waves. What is interference? Interference is nothing but superposition of two waves having equal frequency and nearly equal amplitude and traveling in the same direction. When these two waves superpose, We call it interference. Do we understand this?
Yes,
Do
sir.
we understand this? Yes or no? No, yes.
Yes, sir.
Okay, now if I just classify this, have you noted this down, everyone?
No, sir.
Okay, then I'll give you 2 minutes to note it down. Let me know once you are done. So, if you are done, then we can move ahead. Now, the superposition of waves, we are going to get different sort of phenomena, and this graph or this table or this whatever you call tree symbolizes whatever we are going to do in this superposition of waves. So superposition of waves, we will have interference, we will have beats. Now standing waves is also interference. It's not interference, it is also superposition of two waves having something in the opposite direction. Then we have Lissau's figure. Now this Lissau's figure, the one that we studied in SHM, I did not use the term Lissau figure. It is the superposition of perpendicular waves. Did we do perpendicular SHM? One particle is the one SHM is in this direction, the other SHM is in this direction. Did we do that or not? Huh? This is superposition of perpendicular waves. Did we do superposition of perpendicular waves? Yes or no? Did we do superposition of perpendicular waves? Huh? We don't remember, sir. Anyways, I can't go back to that. So, in stationary waves, we will have to do longitudinal and transverse. First, we will deal with transverse. In transverse wave, this will be a stretched string. We have done something about stretched string, how we can find out the speed of wave in a string. We will then see how we are going to create standing wave. Then this is sonometer wire. We will be dealing with this sonometer wire as well. So this is in short how the things will go till the end of this chapter, which should be coming pretty soon. 2 or 3 classes we should be done with this. No, Doppler effect is left. Maybe by the end of this year we'll end this, and new year we'll start new things. So I'll give you 2 minutes to note this down. So then, since we are done, we will move ahead and we will write the first heading. And what is the first heading, my dear friends? Huh? What will we study first? Amitabh Bachchan.
Beats.
We'll study interference first. I just said that 3 minutes before. Beats we'll do afterwards in sound. So what I feel sometimes listening to your answer is I should tell you the opposite, and then probably that will make more sense to you. So from now on, I am going to tell you, don't study at all. Chill. There is no need to study. Don't ever study. Don't even look at your books. Don't study anything. Forget everything that you have studied. Forget everything. You come to the class, you come in a new mood. कल की बात पुरानी नए दौर में लिखेंगे मिलके नई कहानी हम हिंदुस्तानी. That is the song that you should follow. You should forget everything that has happened day before, and then come with a new spirit tomorrow. And I hope then that you will do the reverse of it, and then you will probably study and come to class after studying. So I'll do the reverse from today. That is known as reverse psychology. I'm not a good psychology student, but I will try to use this reverse psychology. So the first thing that we are going to study is not beats but interference. Interference. What do you mean by interference? What do you mean by interference? Obviously, many a time when I used to ask students what is interference, all of them get confused between interference and superposition. I hope I have made superposition very clear. Superposition can be of wave, superposition can be of electric fields, magnetic field, gravitational field, forces, vectors, anything. Whenever a body is subjected to more than one motion, more than one force, more than one field, the net force or net field or net displacement or net velocity or net acceleration is the summation of all those. Interference is a special example of this superposition. It's a very, 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 very important topic. And it is a superposition of two waves of equal frequency, nearly equal amplitude, traveling in the same direction. These are the 3 points that you must remember. Having the same state of polarization. You may forget this. You may forget this. Then what happens? So what are the conditions of interference? Number one, the two waves must have equal frequency. First, listen to me, then I will give time for you to write. They must have equal frequency. They must have nearly equal or nearly same amplitudes. Traveling in the same direction. Traveling in the same medium. And if you want to have good, persistent or good interference, then they must have a constant phase difference between them. The phase difference should remain constant. If the phase difference varies with time, then we will not have good and sustained interference. So, if all these conditions are met, then what will happen? At some points, intensity is maximum, and at some points, intensity is minimum. This redistribution of energy or redistribution of intensity is known as interference. So at some points you will get very high energy or very high intensity. At some points you will get absolutely almost zero energy or intensity. This redistribution of intensity or energy is known as interference, which is very evident. At some points intensity is very large, whereas at other points it is nearly zero. This redistribution of energy is known as interference, my dear friends. Do we understand this? Yes or no?
Yes, sir.
Pakka na, sir? Now I shall give you time to write it. And we have already covered this chapter, so we'll go move fastly after that. So we've already done this previously also. How are we going to go any further? So now we are going to take two waves. We are going to take the equation of two waves traveling in the same direction. Let me call first wave as y is equal to a1 amplitude sine of omega t minus kx. Omega and k are same because they are traveling in the same medium with the same frequency. Y2 is equal to a2 into sine of omega t minus kx plus phi. Now again I will repeat myself. Some things have been kept same and some things have been made different. What are the things that have been kept same and what are the things that have been made different here?
Different. Sir, amplitude is different.
Yes.
Angular frequency is same. Phase is different.
The wavelength is same because they are traveling in the same medium. The wave velocity is same, frequency is same, the initial phase is different, and the amplitudes are different. Yes or no? No, yes. Huh?
Yes, sir.
Now, if there are two waves, I mean, there can be 10 waves, but normally whenever a question comes, it will come only on two waves. Now, if these two waves are traveling in the medium, what does the principle of superposition say? Remember, they are also traveling in the same direction. In which direction is this wave traveling? Huh? In which direction is the wave traveling?
Positive of x-axis.
So, my dear friends, the resultant amplitude, now the resultant wave can be written as y1 plus y2, and that will be equal to a1 into sine of omega t minus kx plus a2 into plus a2 into sine of omega t minus kx plus phi. Now you already know how to add it, so I can straight away write y as a times sine of omega t minus kx plus xi. Do we remember this? Yes or no? Huh? Do we remember this?
Yes.
Yes, sir. Then, sir, you have to tell me the value of A, sir. What is the value of A? A, which is the resultant amplitude of these two combined wave, the resultant wave. What will be the value of A?
Root over a square plus a1 square plus a2 square plus 2a1 cos phi.
Yes, root over A1 square plus A2 square plus 2 times A1, A2 cos phi. We understand this. There's nothing has changed. Only the wave equation. Instead of SHM, we have the wave equation. Do we understand this? Huh?
Yes.
Now, in this chapter, we have read one more term, which is intensity. I, the intensity of the resultant wave. How can I write the intensity of the resultant wave? Intensity of the resultant wave. Yes, my dear friends. That is why I told you the most important thing that we are going to worry about here is the intensity. We are not worried so much about the amplitude. The only job of this wave is to transfer energy. If it does not transfer energy, it is useless. Huh? Intensity. We don't know, sir. We have no idea, sir. Yes.
Half rho omega square a square v.
Take a deep breath. Open your eyes and give me the answer again. Intensity of the resultant wave will be given by this formula I1 plus I2 plus 2 times root over I1 into root over I2 into cos of phi. Do we understand this? But it has gone above our head saying bye bye, sir. I am going, sir. Bye bye, sir. I'm going, sir. Bye bye, sir. I'm going, sir. Bye bye, sir. I'm going, sir. Huh? Okay, I leave it at that. I have to also find the value of tan of xi. What is the value of tan of xi? What is the value of tan of xi? Tan of xi, my dear friend. Xi.
a2 sin phi divided by a1 plus a2 cos phi.
A2 sine phi divided by A1 plus A2 cos phi. Well done. And how have I added these two waves? I have just used simple common sense. I have drawn the wave A1 here. I have drawn the wave A2 here, which is ahead of wave A1 by a phase angle of phi. And then I have added these two waves and I have got the resultant wave as wave A, which is inclined at an angle of xi. Do we understand this? Do we remember this? I can write the A ka x component as A1 plus A2 cos phi, and I can write A ka y component as A2 sine of phi. Do we remember this? Do we understand this? Yes or no?
Yes, sir.
Pakka?
Yes, sir.
Everyone understands this? If you have any doubts, I will give you 2 minutes. If you have any doubts, please come up and ask those doubts wherever they are from. These are the two most important formulae that we will be using in the days which are coming ahead. I'll give you 2 minutes to note them down. So, welcome back. We have understood this up till here.
Yes, sir.
Now, looking at what we have done, we shall have two types of interferences. The first interference is known as constructive interference. The first one is known as constructive interference, and the other one is known as huh?
Destructive.
The other one is known as destructive, which all of us are. Destructive interference. Okay, now what happens in constructive interference? I'll give you chance to shine here. I'll give you chance to shine here. What will happen in constructive interference? What will happen in destructive interference? Yes. If the phase difference phi is how much? 2n pi, where n starting from 0, 1, 2, and so on. This is known as the even multiples of pi. If phi is 2n pi, that means the value of your cos phi will be how much?
One, sir.
Plus 1, sir.
Yes, sir.
Then your amplitude will be maximum, and that maximum amplitude will come as A1 plus A2. Yes or no? No, yes. Huh?
Yes, sir.
Pakka, sir?
Yes.
Your intensity will be maximum and it will be coming as root over I1 plus root over I2, the whole square. This type of interference where intensity and amplitude of the resultant wave is maximum is known as constructive interference. Do we understand this? Huh?
Yes, sir.
Everyone is sure what I have written here? Now, I can take a special case. If A1 is equal to A2, let me write it as A. I1 is equal to I2. Both the waves are of same amplitude and same intensities. Then what will happen, my dear friends? My maximum amplitude will become how much?
2A.
Ah,
2A.
maximum amplitude will become 2A and my maximum intensity will become
4A.
4 times I. This is when we say the interference is best possible interference, because the constructive interference, wherever constructive interference happens, you will have 4 times intensity of the original waves. 4 times intensity. Now, there is one thing that you must understand here, that for constructive interference, my dear friends, we have said that the phase difference has to be 2 pi. Now, once you know the phase difference, you can also tell me the path difference. If the phase difference is 2n pi, 2n pi, 2n pi, what will be the path difference between the two waves? Because that is going to come in your chapter on wave optics. What will be the path difference if the phase difference is 2n pi? What is the path difference? Anyone? Anyone can tell me the path difference? I have given you the relation between path difference and phase difference previously also. Previously also I have given the
In times of
relation.
lambda, sir.
Huh?
In times of lambda.
N times of lambda. See, if you pay enough attention, you will understand that the path difference would be n times of lambda. N times of lambda, where n starts from 0, 1, 2, and so on. Now, let us look at the flip side. If phi is equal to how much? How much? How much? How much?
Even multiple of pi, maybe.
Maybe. Ah. This is even multiple of pi that was given here. Odd multiple of pi, 2n plus 1 pi. Here n starts from 0, 1, 2, and so on. If you want to start n from 1, you will write it as 2n minus 1 pi. Do we understand it? This is simple maths, trigonometry. Yes or no?
Yes, sir.
And you love maths. Cos of phi becomes equal to minus 1 then. Then I shall have the minimum intensity. And minimum intensity will be A1 minus A2 if A1 is greater than A2, or A2 minus A1 if A2 is greater than A1. What would be the minimum intensity, my dear friends? Yes, I await your answers. I await your answers.
Sir, root I1 minus root I2 whole square.
Root I1 minus root I2 whole square. Now, here also I can do a special case. If A1 is equal to A2 is equal to A, I1 equals I2 equals I, then you will see an astonishing thing happening. Minimum amplitude will be how much?
0.
0. So you will have 0, no wave, no amplitude, no intensity. We call it very good interference. Do we understand this? So this has gone above our head saying bye bye, sir. I'm going, sir. Bye bye, sir. Bye bye, sir. Bye bye, sir. Huh?
Understood, sir.
Okay. Everyone has noted this down. Hmm? Everyone has noted this down? Yes or no? No, yes.
Yes, sir.
Shall I move ahead in life? Life has to move on. Then many a times they might be asking you the ratio of maximum intensities to the ratio of minimum intensity. Then this revolutionary formula would be helping you out. Do we understand this revolutionary formula? This is the revolutionary formula for maximum and minimum intensity ka ratio. I have sometimes seen they ask you the average intensity. So you can note down the formula for average intensity also, and the formula looks like this. Average intensity or percentage of intensity, you can write it as I1 plus I2. If both the amplitudes are equal, intensities are equal, then it becomes average becomes 2I, maximum intensity becomes 4I, and minimum intensity is equal to 0. Do we understand this, or this has gone above our head saying bye bye? Bye bye, sir. Bye bye, sir. I'm going, sir. Please don't stop me, sir.
Understood.
Pakka?
Yes, sir.
Noted this down?
1 minute, sir.
Have we noted it down, bacha?
Yes, sir.
Okay, then there is very important point. What happens in interference? You can see the maximum intensity is root over I1 plus root over I2 ka whole square, whereas the minimum intensity is root over I1 minus root over I2 ka whole square. This is actually the addition wala intensity is root over I1 plus root over I2 ka square is more than the I1 plus I2 by an amount equal to root over I1 I2. Do you see this? Do you see this? The yellow one is I1 plus I2. But this I1 plus I2 is less than root over I1 plus root over I2 ka square. Similarly, the minimum intensity is less than I1 plus I2 by an amount root over I1 minus root over I2. Do we understand this? Therefore, we understand that, as I said, in interference, you don't create energy, you don't destroy energy, but you only redistribute energy. So basically interference is nothing but law of conservation of energy. Do we understand this? Energy is just redistributed. Energy is just redistributed. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down, to draw the graph. So now since you have written this down, let us move ahead and solve a question. Remember whatever question we had done in SHM. Do you remember those questions? There were question of superposition. Do we understand this?
Yes, sir.
This is one question that is going to check whether you have understood the concept or not. Two sinusoidal waves of the same frequency traveling in the same direction along a string. A1 is 3 centimeters, A2 is 4 centimeters, and your phases of the waves are given as phi 1, 0, and phi 2 as pi by 2 radians. They are simply asking you what is the amplitude of the resulting wave. I think you
Five,
can also write the resultant waveform. So I'll give you 2 minutes to do it.
5 centimeters, sir.
Okay, well done. The resultant amplitude is 5. Yes, it's very simple to see. As you can see, if you draw one wave here, that 3 centimeter wala, then the other wave would be here, that 4 centimeter wala, because the other wave is ahead by a phase angle of pi by 2. Yes or no? So the resultant amplitude will be like this. Yes or no? And that will be equal to root over 3 square plus root over 4 square. Yes or no?
Yes.
You can also find out this angle psi, this angle tan of this psi will be 4 by 3. So basically your xi becomes 53 degrees. Yes or no? So you can also find out the phase. Everyone understands this? Yes or no?
Yes, sir.
Same question from SHM and same question here. Now I'll give you this question. Again, similar question. It has got some parts. If you can solve all those parts, that means you have understood this. It can be a question of SHM, it can be a question of anything. So this is the question which I am going to give you as a homework that you will attempt in your home or hostels. Two sinusoidal waves of same frequency are to be sent in the same direction along a taut string. One wave has an amplitude of 5 mm, the other has an amplitude of 8 mm. For what phase difference phi between the two waves results in the smallest amplitude? You know this. How much should be the phase difference, so the amplitude has to be smallest? What should be the phase difference? No one knows it. Okay. What is the smallest amplitude? Second question. What phase difference phi 2 results in the largest amplitude? What is the largest amplitude? What is the resultant amplitude if the phase angle is phi 1 minus phi 2 divided by 2? Do we understand this question, everyone? Yes or no? Do we know the answers for this one? Yes or no?
Yes, sir.
What is the answer for part A? Smallest amplitude. What should be the phase difference?
0, sir.
Take a deep breath. Open your eyes and then give me the answer. In the next class, think about it.
Sir, 1 minute. I'm copying the question.
Yeah. Copy the question. I'll wait. And then please give me the answer in the next class. And I expect that you can give me the correct answer in the next class. The next class, we'll move on to the next ahead and probably start and finish standing waves as well, because the next class is going to be of 2 hours, I guess. So I think we will be able to wind up your standing waves. Let's see if we can do that. So I'll see you in the next class. Take care and God bless you all.